In this video, I'll go over hiding data with steganography. Steganography is the hiding of data inside of other data. Steganalysis, then, is the study of steganography. With steganography, a third party would know, for example, that a data exchange is taking place between communicating parties. But what the third party wouldn't know is that there are secret messages embedded within that communication. Encryption is different because with encryption we know that there's a secret message there. We just can't decrypt it if we don't have the correct decryption key. On a computer, specialized software is required to hide and then to reveal secret messages embedded in other data. There are also tools that can be used to detect abnormalities in files due to steganography, and these tools would be used by forensic technical experts. Steganography has been around for a long time, and it has many different implementations. For example, we could hide the encrypted file in the color bits of a JPEG file, or we could hide an encrypted file in the noisy bits of an audio or video file. We could even send fake or damaged packets between two network devices, where to an external observer, it would simply look like data corruption. In practice, steganography can be used with printers. Printers can add dots to a printed image that contains a unique identifier for a specific printer. Watermarking images or digital content can also be used for digital rights management. This is often done mostly for anti-piracy. Of course, we can also embed secret documents or messages within an image or an audio file, among other types of files. An advantage of steganography is that encrypted data is hidden, so it won't even gain attention like a regular encrypted file would. Disadvantages of steganography include the fact that it can be hard to hide the data in such a way that it's statistically undetectable, because we are modifying the carrier file in which we're embedding our secret message. Also, a large source of data in which to embed the hidden data itself might be required. So in other words, files might be much larger than they otherwise would be. Let's examine steganography in Windows. In my steganography program, I'll begin by opening a JPEG file. After I've opened the JPEG file, the next thing I would do is set a passphrase on the file. So I'll click the passphrase menu option. I will enter a passphrase, and then I'll enter it a second time to confirm it. Then I'll click OK. Now what I need to do is embed a secret message or document within my JPEG image. To do that, I'll go to the Hide menu, where I'll select a text document that I've created called secretmessage.txt. I want to embed that within the JPEG image. Then what I'll do is I'll save the JPEG. Now a message pops up that says that it made a big change to the file and it might be detected, but nonetheless I'll click OK. It's been done. Now to the casual user, if they were to open up that JPEG image, it would look just like a picture, when in fact it contains an embedded file. On the other end of our connection, the other party would have the same software and they would choose to open the JPEG. Then they would enter the passphrase, and then what they would do is seek the data within the picture. For example, I'll choose Open JPEG, and I'll choose Seek. At this point, it asks for the passphrase. So this would happen on the other end of the communication. So I'll enter the correct passphrase and click OK, at which point it says Save the hidden file as, and then I could extract the file and read the contents of the message. In this video, we learned about steganography.